Okay. Okay. Select the problem number 1. Select a suitable V-belt to transmit 15 kilowatt of power to a compressor. Okay. Full stop. The motor speed is 1200 RPM and compressor pulley runs at 400 RPM. Okay, so this is the overall statement of the problem. That's it, nothing more. So whether the given problem is design oriented problem or it is a numerical oriented problem, this
Design.
one is design. How did you come to know that?
Select a suitable rebuild.
So he has given us to select a suitable rebuild to transmit 15 kilowatt of power. Okay, so we shall see how to do this particular problem. So power is 15 kilowatt. That is what the user has given us. Motor speed which is 1200 RPM, and the compressor speed which is NL, which is 400 RPM. Now from this, can I calculate the value of velocity ratio? That is a NL divided by NS, which is 1200 divided by 400. I think it is 3. So we shall start the solution now. So what is the first step in the solution? First step in the design procedure. What is the first step? Please look into the design procedure and let me know. What is the first step? So I guess it is preliminary decision. Please do respond, guys. Preliminary decision. So what are the preliminary decisions that you have to make? Number 1, you have to select a material for a cast pulley, which is cast iron. So assume that the pulley is made up of cast iron. Okay. Next is the step where you calculate the service factor. So on what you are going to calculate a service factor? Based on given power and combination of driving and driven member the service factor is taken as, so Ks is equals to, so please refer the table number 14.19, page number 322 for this. So 14.19 and page number 322. Okay. So this is the service factor. Okay. So what is the information which is available in the problem? What is the information which is available in the problem? Yes. Power is given. So how much is the value of power? 15 kilowatts. Okay, that is one information. So please do respond. Open your mic and speak. Otherwise, it would take more time. What else is given? So what is the driving member and what is the driven member? So driving member, two types are there. Carefully observe here. He says it is type M and type N are the different types of driving member. But actually, the M and N has to be mentioned here. It has mentioned A and B. I don't know why, but it has to be mentioned M and N here. So if any some particular application is given, for example, internal combustion engine is given as a driving member, then you have to go for type A, which is type M, and you have to look in this particular column. And that is the way it works. So I guess type M and N is wrongly printed as type A and type B here. Okay, that is one thing. So the driving member, you will look here. The driven member, you will look it here. So you have to look here. So suppose where you can find your compressors, whether in the light duty, medium duty, or heavy duty. Just check here. Agitators, belts, brake machinery, all sort of machineries are given. Whether the compressor which is given in the problem comes under the light duty, medium duty, or heavy duty, or extra heavy duty, in fact. Medium, where you have medium belt conveyors, sand, grain, dome, fans, generators, line shafts, laundry machines, machine tools, punches, presses, shears.
Heavy duty.
Huh? Positive, rotor, revolving, and vibratory screens. Where is the compressor? Light duty, okay. Heavy duty, yeah. Heavy duty only there. So this is a piston compressor. Piston compressor, Adu. It is not normal compressor. Piston compressor. Look at that. Okay. Light duty. So light duty only pumps and compressors ಬರುತ್ತೆ. So we'll fix upon light duty. So we have fixed upon M. So if nothing is given, you will take M. Okay, the type A you would take. So you're fixed upon M. Now we have to decide whether to take 1.1 or 1.2. Okay, preferably what will you take? If nothing is given, always consider continuous service, because you never know your machine is running for 8 hours, you never know your machine is running for 4 hours, 5 hours and nothing. So preferably what to assume that if I give the maximum load to my machine, the machine should be safe. That is your predominant assumption. That's why you assume it to be a continuous service and take the service factor as 1.2. Take that particular thing and come back here. Okay, 1.2, just write it as 1.2 there. Very good. So assuming, you can write a statement assuming light service and operating conditions. Light service and operating conditions, operating continuously. Okay, just write that statement. Step number C in the design procedure. It says design power has to be calculated. So how do you calculate your design power? It is very simple. P to the suffix D is P cross Ks. Okay, so that is P is 15 cross 1.2. It would be 18 kilowatts. So the design power is 18 kilowatts. Now, this is the very important step. Okay, very, very important step. So, based on the design power, you are going to select the belt. So, belt selection you are going to do, which type, whether A, B, C, E or E. So, you have to check according to the ranges given there. So, for that, you may have to refer the table number. So, from table number 14.14, page number 314. So all of you just move to that table, 14.14, page number 314. Yes, this is very, very important table, guys. Very, very important. So how do you have to select the belt is, so you are calculating the stuff in kilowatts. So please do refer the kilowatts ranges here. So in this particular range, so your design power is 18 kilowatts. 18 kilowatts sits where? In which range does it come? Yes, so we shall select C belt. All of you agree on this? 10 to 70. So pick the C belt there. So just write this sentence PD is equal to 18 kilowatts, which lies in the range. For the first problem, I'll be writing all the statement, guys, for you to make sure the procedure what we follow. From the next problem, even in your examination also, you're not supposed, like, it is not mandatory that you have to write each and every statement what I write. A precise, crisp statement, if you write, that's more than enough. But statements are necessary, I'm telling you that. Okay, range of 10 to 70 kilowatts. Even you, please do write it for the first problem. From the second, it's left to you. Select C type of belt. Okay, so this is what we have done. immediately what you have to do whenever you select a belt, three parameters which are there for that particular belt category has to be noted down. The number one is nominal top width. Nominal top width has to be noted down. Next, nominal thickness. This has to be noted down. Next, maximum velocity, Vmax. This has to be noted down. So I guess when I look the data handbook, I have all the values here. I'll pick that value. So nominal top width is 22 mm, nominal thickness is 14 mm, and maximum velocity is 25 meters per second. So when you note down all these values, your second step gets completed. Now the third step, diameter. Pitch. Remember, it's not just a diameter, it's a pitch diameter of motor pulley, which is the driver. Okay, so we have small d is equals to 630 cube the root of design power, which is in kilowatts, divided by omega max. And this particular equation I have taken it from 14.9a, page number 292. Okay, from this, where you might have to calculate the value of omega max, that is equal to 2 pi n max divided by 60. You have 2 pi 1200 divided by 60, that is equals to 1 rats per second. So once you get that value, please substitute even here. So what is the omega max value? $125. $125.1666. So 125.66. Please do substitute and give me the value of D. So 329.66 mm. So you need to standardize this value. So standardizing above pitch diameter using table number 14.22 in the page number 326. Please go to that table number 14.22. So you'll be having yes. So here is your diameter. Okay. So always you have to go with the nominal value. So you please mention a star near the nominal value. So always you have to look for nominal value. This, you don't need to bother about this. Keep this in mind. Look for the nominal value. Now, so there is a procedure to be looked forward. So whatever the value you select in the nominal value, okay. So suppose if you select for in case you select 125 as your standard value, okay. So based on the type of V belt that you have selected, suppose if you have selected B, on that particular category, the preference has to be 1 always, never the 2. If it is 2, you have to jump to the next belt. For example, let us see for this case. It is 400 mm. Okay. Now, here it is 400 mm. Okay. Fine. So now, right, fine. 400 mm. Where is 400? So here is your 400 mm, right? Wait. What I will do is 320 nalla. I would just write here A, B, C, D, and E here, so that it would be convenient for us to discuss. Okay, fine. Now, what is our value? What is our value? What we have got, it is 329, isn't it? 329, or approximately can take it as 330. So without any knowledge, I have said that you have to always look for the nominal value that is in this range. So which is the value that you would suggest preliminarily? Which is the value that you would suggest? My value is 330, 355. So where is the 355? Look here. Okay, 355 you have selected. Now, what is the condition I'm talking you? So based on the belt that you have selected, for that particular belt, the preference has to be 1. So what is your belt selected here? What is your belt selected here?
C.
It's a belt selected is C. Now look for C now. What is the preference given? What is the preference given? 2. So 2 not allowed. Only 1 is allowed. Next, go for the next option. What is next option? 375. For 375, what is the preference given? For 375, again it is 2. So again it is not allowed. Go for the next one. Next, for the next selection, which is 400, what is the preference given? 1. Now you have to pick 400. Understood this procedure of picking up the things? Understood? So that is why I say classes are important. Okay? Good. Good. So I cannot make this as a design procedure for you. Okay? I cannot write each and everything. So this is very important to be understood. Yes? ಹೇಗೆ ಹೇಳಲಿಕ್ಕಾಗ್ತದೆ ಇದನ್ನೆಲ್ಲ ಕತೆ ಕಥೆನ? So better, I hope you have understood, guys. Otherwise, I will repeat it once again. So we have to keep on increase the next value, increase the diameter unless and until you reach 1, preference number 1. Okay, so that is the funda. So come back here and standardizing the above, I can just write it here. You can just write a note if you want. So just write a note like this, note. Before to that, I would just write the standardized procedure. Value. So standard value is how much? It is 400 mm. Okay. Just put it in a box. After that, you can write note for your clear understanding. So note. You can just write as take nominal value. take nominal value and select next standard with 1 as a preference with respect to the belt type. Just write it and leave it. Okay. So I guess reading this sentence and getting to know what exactly it is difficult. So hope I have explained it clearly. So anyhow, we'll be coming across such situations many times. So we'll get to know the things very fast. Okay. Okay. Next, the fourth one. Pitch diameter of the driven pulley. So next, you have to calculate the pitch diameter of the driven pulley. So how do you calculate it? It's pretty easy. So capital D is V times the I. So 400 you have cross 3. So how much it is? 200, 1200 mm. So capital D. Now standard size. For 1200. Please look into the same thing and give me the value of standard size using the same table reference. This one, table number 14.22, page number 326. Looking at the same table, please do standardize 1600. Okay. $1200. Oh, 1250, yeah? Okay. Shall I take it as 1250? ಏನಾದರೂ ಪ್ರಾಬ್ಲಮ್ ಇತ್ತಾ ಶಿಫ್ಟ್ ಆಗೋದು ಏನಾದರೂ ಪ್ರಾಬ್ಲಮ್ ಇತ್ತಾ ಅಥವಾ ಡೈರೆಕ್ಟ್ ಆಗಿ ಸಿಕ್ತಾ ಪ್ರಿಫರೆನ್ಸ್ 1 ಗೆ ಡೈರೆಕ್ಟ್ ಮತ್ತೆ ಅವನು ಸಾದ್ ಏನಕ್ಕೆ 1600 ಅಂತ ಹೇಳ್ದ ವಾಟ್ ವಾಸ್ ದ ಪ್ರಾಬ್ಲಮ್ ಸರ್
ಅದು ಬೈ ಮಿಸ್ಟೇಕ್ ಸರ್
ಅಚ್ಚಾ ಈಗ ರೆಕ್ಟಿಫೈ ಆಯ್ತಾ ಅದು
Yes, sir.
So 1250 is the standard size. Now, if you change the diameters after you standardize the values, definitely the velocity ratio would change. So you please do calculate the standard sizes you just mentioned in the step 5 to calculate the revised velocity ratio. Standard sizes. First one is driver pulley. So this is what you are giving it to your designer. Your designer, no, you will be giving all these details to the manufacturer. This driver pulley should be of 400 mm that you will specify, and you will sign at the bottom. Okay, and driven pulley should be of, which is of the compressor. So that should be of how much? 1250 mm. Okay, since this is changed, what will you calculate? You will calculate the revised velocity ratio. Revised velocity ratio is I is equals to capital D by small d, which is 1250 divided by 400. That is equals to 3.125, I guess. Okay. Okay. Next, sixth one. So once you calculate all the sixth one is the belt speed. So belt speed V is equals to pi d n by 60. It is pi into 0.4 into 1200 divided by 60, which is equals to 25.13 meters per second. I guess it is approximately equal to Vmax, right? So where did you get the Vmax? Anyone? Do you know the value of Vmax? ನಮಗೆ ಗೊತ್ತಿದೆನಾ ಮ್ಯಾಕ್ಸಿಮಮ್ ವೆಲಾಸಿಟಿ ಎಷ್ಟಿರಬೇಕು ಆ ಒಂದು ಬೆಲ್ಟ್ ಕ್ಯಾಟಗರಿಗೆ ಅಂತ? Yes. So Vmax value was 25, I guess. You have taken it while you are selecting the type of belt. Suppose C belt select ಮಾಡಿದ್ದೀರಾ, ಅದಕ್ಕೆ Vmax ಎಷ್ಟಿರಬೇಕು ಅಂತ ಆಲ್ರೆಡಿ ಬರ್ಕೊಂಡಿರ್ತೀರಾ. ಸೊ ಆ ಒಂದು Vmax ವ್ಯಾಲ್ಯೂ ಈ ಒಂದು ವ್ಯಾಲ್ಯೂ ಕಮ್ಮಿ ಇರಬೇಕು. Vmax ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇರಬೇಕು. ಒಂದು ಬೆಲ್ಟ್ ಸ್ಪೀಡ್ Vmaxಗಿಂತಲೂ ಕಮ್ಮಿ ಇರಬೇಕು. ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಸೇಮ್ ಇದೆ ಕಾರಣ ತೊಂದರೆ ಇಲ್ಲ. ತುಂಬಾ ಡಿಫರೆನ್ಸ್ ಬಂತು ಅನ್ಕೊಳ್ಳಿ, then you have to change the belt type. Okay, so rare cases ಅಲ್ಲಿ ಆಗುತ್ತೆ, ಡೋಂಟ್ ವರಿ. ಓಕೆ, ಅದು ನಿಮ್ಮ ಇಂಜಿನಿಯರಿಂಗ್ ಪ್ರಾಬ್ಲಮ್ಸ್ಗೆ ಬರುವಂಥದ್ದು ಕಷ್ಟ. ಇಂಡಸ್ಟ್ರಿಯಲ್ಲೆಲ್ಲ ಹಾಗಾಗುತ್ತೆ. So you are changing the belt type and again you have to do all the calculations from the first. Okay. So always have a check once you calculate V. So Vmax ಎಷ್ಟಿತ್ತು, ನನಗೆ ಬಂದಿರುವಂತ actual speed ಎಷ್ಟು. So just have a comparison. Next, you calculate approximate center distance. Why approx? Because the full length exact center distance you cannot calculate as of now. So first calculate approx center distance. Approx center. Hope you are parallelly observing the design procedure as I'm writing it. Is every step synchronizing with the design procedure what I have given you? Are the steps synchronizing there with the design procedure what I am giving you? Okay. Approximate center distance. So C approx is given as 1.5. This is the thumb rule. Every industry follows 1.5 times of capital D plus small d. So even it has been mentioned in equation number 14.2 D on page number 290. You can have a look there. Okay. From this, please do calculate approximate center distance 1.5 times of 1250 plus 400. So how much is this? See approx. Okay, 3675, 2475. Yavudu correct? 2475. Sure, okay, fine. 2475 is the approximate center distance. Or now, why do you require this approximate center distance? Just because you might have to calculate in the next step the pitch length of the belt. So pitch length of the belt. So many of you have complained, like not complained, but suggested that it's becoming difficult because every formula is not orderly arranged in the data handbook. It is randomly. So you can find one formula here, 2 pages after next formula. So I know that. So for that particular reason, what you have to do is whatever the design procedure I have given you, so please do follow the same procedure. By heart ಆಗಬೇಕು 7 approximate distance calculate ಮಾಡಬೇಕು 8 pitch length calculate ಮಾಡಬೇಕು ಈ ತರ by heart ಆಗಿಬಿಟ್ರೆ ನಿಮಗೆ ಫ್ಲೋ ಮಿಸ್ ಆಗೋದಿಲ್ಲ ಪ್ರಾಬ್ಲಮ್ ಇದು pitch length of the belt ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಾ you can use that formula L is equals to 2C plus 1.57 capital D plus small d plus capital D minus small d its whole square divided by 4C. So where are you taking this particular equation? From 14.15 B on the page number 295. So please do substitute. So C, you are substituting it as approx. Keep this in mind. So 2 times of 2475 plus 1.57 capital D is 1250 plus 400 plus that is 1250 minus 400 its whole square divided by 4 times of 2475. So from this, what is the length of the belt? Okay, 7613.5. So standardized above well length, pitch length using table number 14.17. Table number 14.17 and the page number 315. Let us have a look at what it contains. Another 315 page number. So this is okay. Belt section yav now select ಮಾಡಿರೋದು. We have selected the belt section as C. So you have to look for here. Okay. C section ಅಲ್ಲಿ ನೋಡಬೇಕು. So column number 4. So column number 4 is belt type C. Very good. And this is inside length. Nominal inside length. Number value ಎಷ್ಟಿದೆ 7625 7613 7613. So which is the standard value left? So okay, I'll just zoom out. Seven six two five. Okay. 8387. ಏನಕ್ಕೆ 8387? Why not 7625? Sumit, justify ಮಾಡ್ತೀಯಾ ಏನಕ್ಕೆ ನಾವು 8387 ತಗೋಬೇಕು ಅಂತ?
ಕರೆಕ್ಟ್ ಉಂಟು ಸರ್. 7625.
ಓಕೆ. ಸೊ 7625 ತಗೊಳ್ವಾ ನಾವು? ಸೊ 7625 ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, always you have to come back and note down the nominal inside length as well. Okay. So this is the nominal inside length 7569. Both the values very vaguely. Okay. So what you have to write is standardizing the above. So L is nominal pitch length. This one is 7625 mm. And even parallelly you have to note down one more parameter, which is known as nominal inside length. It is today 7569 mm. So even you have to note down this. Okay. Nominal inside length with a nominal length. This is what? This is just nominal length. This is nominal inside length. ಏನಂತ ಗೊತ್ತಾಗುತ್ತಾ ನಾಮಿನಲ್ ಲೆಂತ್ ಮತ್ತು ನಾಮಿನಲ್ ಇನ್ಸೈಡ್ ಲೆಂತ್ಗೆ ಡಿಫರೆನ್ಸ್? ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ತೀನಿ, ಅರ್ಥ ಆದರೆ ಒಳ್ಳೆಯದು, ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದರೆ ಇನ್ನೂ ಒಳ್ಳೆಯದು. ಓಕೆ, ಈಗ ನೋಡಿ, ನಾನು ಎರಡು ಬಣ್ಣದ್ದು ಕಲರ್ ಹಾಕ್ತೇನೆ. ಸೊ ನಾಮಿನಲ್ ಲೆಂತ್, ನಾಮಿನಲ್ ಇನ್ಸೈಡ್ ಲೆಂತ್ ಬಂದ್ಬಿಟ್ಟು ನಾನು ಬ್ಲೂ ಅಲ್ಲಿ ಹಾಕ್ತೇನೆ. ನಾಮಿನಲ್ ಇನ್ಸೈಡ್ ಲೆಂತ್ ಬಂದ್ಬಿಟ್ಟು ನಾನು ಬ್ಲೂ ಅಲ್ಲಿ ಹಾಕ್ತೇನೆ. ಸೊ ಇದು ನಾಮಿನಲ್ ಇನ್ಸೈಡ್ ಲೆಂತ್. ಓಕೆನಾ? ಈಗ ನಾನು ನಾಮಿನಲ್ ಲೆಂತ್ ರೆಡ್ ಅಲ್ಲಿ ಹಾಕ್ತೇನೆ. ಓಕೆನಾ? ನಾಮಿನಲ್ ಲೆಂತ್ ರೆಡ್ ಅಲ್ಲಿ ಹಾಕ್ತೇನೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ನಾಮಿನಲ್ ಲೆಂತ್. ಅರ್ಥ ಆಯ್ತಾ? ಇನ್ಸೈಡ್ ಲೆಂತ್ ಅಂದ್ರೆ ಗ್ರೂ ಕೆಳಗಡೆ ಇರುವಂತದ್ ಲೆಂತ್. ನಾಮಿನಲ್ ಲೆಂತ್ ಅಂದ್ರೆ ಸೆಂಟ್ರಾಯ್ಡ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ತಗೊಂಡಿದ್ವಲ್ಲ ಲಾಸ್ಟ್ ಟೈಮ್, ಆ ಥ್ರೂ ಸೆಂಟ್ರಾಯ್ಡ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವಂಥದ್ದು ನಾಮಿನಲ್ ಲೆಂತ್. If you get it, it's well and fine. If you don't get it, it's still well. Nominal inside length 7569. Next, you calculate the exact center distance in the next step. Step number 9. Exact center distance. So that is given by C is equals to A plus square root of A square minus B. What is this A and B? Okay. A is L divided by 4 minus pi into capital D plus small d divided by 8. So that is equals to 7625 divided by 4 minus pi times of 1250 plus 400 divided by 8. So this is the value of A, and this is the value of B, which is capital D by small d by 8 x whole square. So that is 1250 minus 400 by 8 x whole square. So that is the value of B. So once you got A and B, you can substitute there to get the value. ಯಾರಿಗಾದ್ರೂ ಗೊತ್ತಾ ಇಷ್ಟೆಲ್ಲ ಫಾರ್ಮುಲಾಸ್ ಹೇಗೆ ಬಂತು ಅಂತ? Anyone knows how did I get this formula? ಅಥವಾ ಇವೆಲ್ಲ ನೆನಪಿಟ್ಕೋಬೇಕಾ? 1258.9. Okay. That is the value of A. Good sir, 1258.29. That a handbook. So you will get all this stuff in that handbook in page number 14.15. Please give the please give the page number. The question number is 14.15. Page number 295. Okay. Now calculate the value of B and hence the value of C. Okay, what is that? 11289. What is that now? Okay, 11 value of B, 11289. So substitute it. It would be 12558.3. I would take it as 3 plus square root of 1258.3 its whole square minus 11289. So exact center distance is how much? 2512, okay, 2512.08 mm. So this is your exact center distance. When you place a belt at exact center distance, no, the tension would be maximum. ಇಷ್ಟು ಎಕ್ಸಾಕ್ಟ್ ಸೆಂಟರ್ ಡಿಸ್ಟೆನ್ಸ್ ನಾವು ಕೊಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ, ಅದನ್ನು ಇದಕ್ಕೂ ಕಮ್ಮಿಗೆ ಇಡ್ತಾರೆ. ಇಷ್ಟು ಜಾಸ್ತಿ ಸೆಂಟರ್ ಡಿಸ್ಟೆನ್ಸ್ ಇದು ಎಕ್ಸಾಕ್ಟ್, ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಹೋಗ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ ಆ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ವಿ ಬೆಲ್ಟ್ಗೆ. ಇದು ಮ್ಯಾಕ್ಸಿಮಮ್. ಇದಕ್ಕೂ ಕಮ್ಮಿ ಹೋಗೋದು ಕಮ್ಮಿಯಲ್ಲೇ ಇರ್ತವೆ ಯೂಶುವಲಿ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ವಿ ವಿಲ್ ಟ್ರೀಟ್ ಇಟ್ ಆಸ್. ಓಕೆ, ನಂಬರ್ 10, angle of contact. This is easy, you already calculated many times. Okay, so theta s is equals to pi minus 2 times of sine inverse of capital D minus small d divided by 2c, and this particular equation has been taken from 14.1a, which is on the page number 289. So just substituting the values, you have pi minus 2 times of sine inverse of 1250 minus 400 divided by 2 times of 2512 from this, the value of theta s. Minus 18.5. ಹೇಗೆ ಸಾಧ್ಯ ಮೈನಸ್ ಬರಲಿಕ್ಕೆ? 16.33. ಏನಕ್ಕೂ ಮೈನಸ್ ಬರುತ್ತದೆ? minus 16.33. Shift by minus 2 shift sine inverse 1250 minus 400 divided by 2 times of 2512.08. ಹೌದಲ್ಲ, ಮೈನಸ್ ಅಲ್ಲಿ ಏನಕ್ಕೆ ಬರ್ತಾ ಇದೆ? 2.8 ಹೇಗೆ ಬಂತು ನಿಮಗೆ?
ಕನ್ವರ್ಟ್ ಮಾಡಿ.
ಓ, ಕ್ಯಾಲ್ಕುಲೇಟರ್ನ ರೇಡಿಯನ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಲಿಕ್ಕಾ? ಓಕೆ, ಸೊ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಯಾವುದೋ ಒಟ್ರಾಸಿ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಇದೆ. ಎಸ್, ಓಕೆ, 2.8. So this is 2. .8 radians. Okay. Next formula. What do you mean by next formula? Mithun? ಓಕೆ, ಎಲ್ಲರಿಗೂ 2.8 ರೇಡಿಯನ್ಸ್ ಬಂದಿದೆನಾ? ಸಾರಿ, ಈಕ್ವಲ್ ನಿತಿನ್ ಸರಿ ಕೇಳು, ನಂಗೆ ಅರ್ಥ ಆಗ್ತಲ್ಲ ಏನು ಅಂತ ಹೇಳ್ತಾ ಇದೆ ಅಂತ.
ಅಲ್ಲ ಈಕ್ವಲ್ ಅಲ್ಲ, ಅದು ಪೈ ಮೈನಸ್ ಡಿ ಮೈನಸ್ ಡಿ ಬೈ ಸಿ.
ಹಾ, ಅದನ್ನ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರ್ತದೆ? ನಾವು ಇದನ್ನೇ ಯೂಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಅದಾದ್ರೆ ಎಷ್ಟು ಬರ್ತದೆ? ಈ ಪೈ ಮೈನಸ್ ಡಿ ಡಿವೈಡೆಡ್ ಬೈ 2c ಮಾಡಿದ್ರೆ
2.8.
ಸುಮ್ಮನೆ ಅದನ್ನೇ ಯೂಸ್ ಮಾಡಿ, ಇದನ್ನ ಎಂತಕ್ಕೆ ಯೂಸ್ ಮಾಡಿದ್ರೆ? ರೇಡಿಯನ್ಸ್ ಅಲ್ಲಿ ಬರೋದಲ್ಲ, ಅದನ್ನೇ ಯೂಸ್ ಮಾಡಿ ಮಾಡ. ಇಲ್ಲ ಅಂತ ಇದನ್ನ ಏನ್ ಮಾಡ್ತೇನೆ ಅಂತಂದ್ರೆ, ಈಗ ಪ್ಲಸ್
ಡಿ ಮೈನಸ್ ಡಿ ಬೈ ಖಾಲಿ ಸಿ ಅಲ್ಲ.
ಎಂತದು?
Denominator only C, not 2C.
ಹೌದಾ? ರೈಟ್. ಈಗ ನಂಬರ್ ಆಫ್ ಬೆಲ್ಟ್ಸ್ ಎಂಬ ಕಾನ್ಸೆಪ್ಟ್ ಏನಿದೆ, ತುಂಬಾ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಇದೆ. ಸೊ ದಟ್ ಈಸ್ ದ ಮೇನ್ ಅವ್ಯಾಲ್ಯೂಯೇಟರ್ ಸೀಸ್. ನೀವು ಇಷ್ಟೆಲ್ಲ ಜಾತ್ರೆ ಮಾಡಿದಿರಲ್ಲ, ಇಷ್ಟೆಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡಿದಿರಲ್ಲ, ಅವೆಲ್ಲ ನೋಡ್ ಸಹ ನೋಡೋದಿಲ್ಲ ಅವರು. ಸೊ ದೇ ವಿಲ್ ಡೈರೆಕ್ಟ್ಲಿ ಲುಕ್ ಇನ್ ಟು ನಂಬರ್ ಆಫ್ ಬೆಲ್ಟ್ಸ್ ಎಷ್ಟು ಬಂದಿದೆ, 6